Hello everyone, I am Dr. Devapa BM, Assistant Professor of Physics, Government College for Women Kolar. Welcome to my video lecture on work and energy, work done by spring force, conservative force and non-conservative force. Session number 17. In this topic, we will discuss on spring force, conservative and non-conservative forces. Point number 1, work done by spring force, expression for elastic potential energy, conservative force, examples to conservative force, non-conservative force, examples to non-conservative force. Learning objectives: to make the students understand derivation of expression for work done by spring force and elastic potential energy. Derivation of expression for elastic potential energy. To define conservative force, mention examples to conservative force. To define non-conservative force, mention examples to non-conservative force. Learning outcomes: students are able to derive expression for work done by spring force, derive expression for elastic potential energy, distinguish between conservative and non-conservative forces. Now let us take work done by a spring force. I will consider a spring whose one end is fixed to a rigid support, the other end is fixed to a block which can slide over a smooth horizontal surface. When the block is displaced, the spring is extended by certain distance x. The restoring force is developed in spring and restores original position. By Hooke's law, restoring force is directly proportional to displacement. Restoring force is F, directly proportional to x. F is equal to minus kx, where minus k is called constant of proportionality. K is spring constant or force constant. The spring force restores the spring and work done by spring force Ws is equal to integral of xi to xf f of x dx. Now Ws is equal to integral of xi to xf minus kx into dx. Minus k is a constant. Pull it outside the integrand. Integral of x is x square by 2. Substitute the limits of integration xi to xf. Now Ws is equal to minus of k into xf square minus xi square. This is expression for work done by spring force. If a spring starts from relaxed position, initial displacement is 0, final displacement xf is equal to x. Now work done by spring force is equal to minus half k x square. Now spring force is a conservative force, therefore which can be derived from negative of potential gradient. Spring force Fs is equal to minus dus by dx, where dus by dx is potential gradient. Minus kx, which is spring force Fs, is minus kx, and minus dus by dx. Now cross multiply this. Dus is equal to minus kx into minus dx, which is equal to kx dx. But therefore integral of dus is equal to integral of kx dx. Now k is a constant, integral of x is x square by 2. Therefore spring potential energy is equal to half k x square. This is expression for elastic potential energy. Conservative force. Conservative force: if the work done by a force in displacing a particle from one point to another point is independent of the path followed by the particle, then the force is said to be conservative force. Examples: gravitational force, elastic force, electrostatic force, etc. Now I will consider a particle which is displaced from point A to point B by force along two different paths P1 and P2. Now work done along path P1 is WAB along path P1 is equal to integral of A to B along path P1 FDS. Work done along path P2 is WAB along path P2 is equal to integral from B to A along path P2 FDS. According to definition of conservative force, work done along different paths is same. Now total work done is equal to sum of work done along path P1 plus sum of work done along path P2. Now W is equal to integral A to B along path 1 FDS plus integral B to A along FDS along path P2. Now I will change the limits of integration. W is equal to integral A to B along path P1 FDS minus integral A to B P2 FDS. This subscript P2 just indicates the path which does not do anything with the limits of integration. Similarly, P1 also just it is a notation for path, does not do anything with limits of integration. So therefore, total work done along path P1 minus total work done along path P2 is 0. Total work done along a closed path is 0 in a conservative force field. Non-conservative force. Non-conservative force. If the work done by a force on a particle that moves between 2 points depends on the path followed, then the force is said to be non-conservative force. Examples: frictional force, viscous force, etc. When a non-conservative force does work on an object, the mechanical energy of the system changes. Now I will take an example: work done by kinetic frictional force. Consider a block of mass m sliding across a floor. A kinetic frictional force Fk vector stops the block during the displacement vector d. The dissipated mechanical energy is total work done is equal to work done by kinetic frictional force. So that is vector Fk dot vector d, which is equal to horizontal component of Fk is Fk cos 180 degree. Why? Because theta is 180 degree. This is the direction of application of the force. This is the direction of kinetic friction force. Total angle is 180 degree. So which is equal to minus Fkd. This appears as a dissipation of the energy. Summary. So far, derived expression for work done by spring force, derived expression for elastic potential energy, defined conservative force, mentioned examples to conservative force, defined non-conservative force, mentioned examples to non-conservative force. Thank you.